Hello, my name is Vladislav. I'm a VTM group engineer, and today the machine 9D714 is presented to your attention. This machine is designed for balancing rotors weighing from 0.6 kilograms to 60 kilograms. All the main characteristics can be found on our website. There are also versions of this machine with a maximum weight of the part up to 10 kilograms and up to 30 kilograms. So let's move on this video to the device of the machine and also to the principle of operation on it and to the procedure for installing the machine. The machine consists of a bed and a second measuring support, a first measuring support, a belt drive located inside the bed. The belt drive has the ability to move when unscrewing these screws 4 pieces and moving along these grooves. It also has 4 fixed positions for movement. The support consists of a fixed part of the support, the measuring part, and then a bar for setting the height of the adjustment and a bar with rollers. Also included are strips with prisms and additional prism for the fixation of the rotors and again the lower one. Also included are 2 additional axial stops in addition to those that you see on the machine. Also top guards and laser sensor. These 2 handles are used to adjust the height of the support. We let them go on by moving this lamp. We raise or lower the roller block up or down. After that, we fix the supports in the desired position, exposing so that the rotor is in horizon. A similar control system for the same support. Inside is a belt drive. There are 2 pulleys on the belt drive in order to have a larger range of the diameters for these parts as well as in speed, so that these parts can be rotated in a wide range of speeds. The tension of the belt drive is carried out by this lamp, which is located on the end part of the belt drive movement lever. Turning the knob clockwise loosens the belt, while turning it counterclockwise tightens the drive belt. The control panel consists of a personal industrial computer, as well as buttons and switches for controlling. Stop rotation button, start rotation button, rotor speed adjustment, indicator light for reaching the required rotational speed, reverse or forward. 3 position switch to select the intensity of acceleration and deceleration of the rotor, and also manual automatic operation of the machine. Computer power button, USB output. The main switch for turning on the machine is located on the left side. There are 2 lamps next to it. One of them is readiness of the drive, the second is voltage. The laser sensor is installed by unscrewing this lamp handle and moves to any of the planes. It's advisable to set it that the pointer, that is a laser mark, shines on the vertical plane of the rotor and some angle with respect to the rotor. This is necessary in order to have correct readings of revolutions, as well as convenience in correcting imbalances. 2 LEDs are installed on the laser sensor. Green indicates that it's powered on, and the orange diode lights up at the moment when a contrast mark passes opposite the sensor laser. This indicates that the sensor is working correctly. If you don't have the sensor triggered when passing the mark, you can either bring it closer, or there are 2 potentiometers. Here you can add sensitivity with the sensitivity adjustment potentiometer, and then the indicator will light up. The second potentiometer is for selecting either dark or light marks. Unscrew lamp, moving along the rack, you can choose any plane for installing the sensor and fix it. On the screen we see that we have standard Windows 7 installed and there is a balancing program on it. The measuring device in this case is PAC1 with a tracking system in English. In order to set up the machine for part start balancing, you must go to the mode and select calculation. Next, we select options according to the accuracy class of the rotor, or according to the specific residual imbalance, or according to the residual imbalance of the rotor. In this case, according to the specific residual imbalance, we set the balancing tolerance to 1 micron, the radius of the rotor is set to 80 mm, the distance from the center of mass is 260 mm, the mass of the rotor is 16 kg. Also, in the calculation mode, you can calculate the balancing tolerance using the tab according to the rotor accuracy class. To do this, select it, press help, and moving between the accuracy classes of the rotor, we select the type of the rotor such as we have installed on the machine. When we have determined that our rotor corresponds to any accuracy class, we press exit and then we set the accuracy class here. After that again, the radials are entered, the distance from the center of mass, the mass of the rotor is press calculation, and we get a tolerance of the balancing. If you want to calculate imbalance tolerance, then go to the third tab, and here is a column we immediately indicate the balancing tolerance in units of grams per millimeter. We set the radial, press the calculation and get the tolerance for the balancing. In order to get a balancing tolerance, click calculation, we get a balancing tolerance in grams. Press enter to continue. Further, here the balancing tolerance for the first and second plane is set, here the test weight is 10 times the tolerance, and here the test weight which is available from 5 to 20 unit allowable masses. 1 gram we will leave, press enter to start. Next we perform a launch without file load. Select the start, press start rotations, start measurement, set the rotation speed, (1150 RPM), wait to stop the rotation button to become active. And the stop button has become active. After that we look at the stability of the display of angles and values. So everything is pretty stable. We press the stop measurement button and the stop rotation button. We select a trial run with a load of 1 gram in plane 1 to 0 degrees. By rotating the rotor, we set it to that there is a 0 degrees here, plus or minus. After the launch without weights, we launch with the test weights installed on the first plane. We install a weight of 1 gram on first plane. Press the start rotation button. After reaching the speed, press the start measuring button. The stop button has become active and we are looking at the stability of the display of angles and values. Everything is pretty stable right now. Press the button stop measurement, stop rotation. Then we select a test run with 1 gram, test weight on plane 2 at 0 degrees. We remove the weight from the first plane. We bring the rotor in such a way that the mark lights up and 0 is vertically on top, and install a weight of 1 gram on the second plane. Click start rotation. Again, we wait until the indication that the speed has reached the set on the lights up. Press the start measuring button. Further, the indication of the stop measurement button has become active. We visually observe the stability of the display of angles and values. Everything is stable. We press the stop measurement button and the stop rotation button. We have completed all 3 launches and press the result button and save the rotor under the name rotor 2. Then we press save. Here we see the magnitude of the imbalance in the second plane, in the first plane, and the angles at which this imbalance is located. After setting up, we remove our turning weight and proceed to weighting the weights.
И переходим к взвешиванию грузиков.
So in this case 100 milligrams on the left side should be placed and 170 milligrams on the right side. Here you need to set the addition of mass. We combine vectors of these masses. Then we install the rotor so that the imbalance indicator coincides with the mark, and vertically from above in the plane in which the laser shines we set our 100 milligrams to the first plane. Then we combine again a vector imbalance with a label on the second plane. Our is 170 milligrams. Press start rotation on both planes we got into tolerance. Button stop become active, both planes are in tolerance. You can click the stop measurement button right now. Next, a report is generated when the first start is selected as the initial start and the last start as the final start. Click the Create button. A report is displayed here which shows the name of the rotor, the speed at which balancing took place, the radius of installation of the control weight, the radius of correction along the first and second plane, and the value of tolerance for balancing along first and the second plane, the initial unbalance or the final unbalance. Next you can see the artist name and date. This report can either be saved or sent for printing. Also in Functions tab there are additional functions that help with balancing the rotors. There is a balancing in 3 optimal planes, harmonic analysis, recalculation to drilling depths, location of loads at fixed points and many others. The machine is connected on the left. The wiring diagram is located on the cabinet door. If necessary, you can refer to it. When connecting to the machine, the vibration sensor cables pass through the white corrugation, go into the cabinet and connect the appropriate connectors. The machine is connected here with a 380 volt cable. Connection of the electric motor with connector XS1 and grounding is required.